inverted. So that minimizes that friction of motion, and it also keeps the robot more stable. It keeps the center of mass in the middle. Right, so now the robot is being walked out here, being teleoperated with a joystick, and it knows how to balance itself. Wave high, hey. Very friendly design. Atlas can lift up to 30 kilograms continuously, that's 66 pounds. It's got a vertical reach of 2.3 meters or 7.5 feet. It's also very good for bending and reaching things. And our focus is on industrial tasks. We're working today with Hyundai. These prototype robots are working in Hyundai factories like the Metaplan America, doing tasks like sequencing. That rack right there, that's an automotive sequencing rack with actual Hyundai roof. That is a real part and a real rack from Hyundai. And we're going to do a lot more with Hyundai. So with the new version here, we're going to be building a lot of these. We're going to be scaling and putting them in more and more Hyundai factories and doing additional tasks. We'll go from automotive sequencing to kitting, machine tending, all the way to the holy grail of general assembly. Also doing things with the logistics industry, thinking about order building. The way that the robot works autonomously, if you get a chance to come by later and see our other longer demonstration, is it's behavior cloning or learning from demonstration. It means that we teleoperate and demonstrate a task to the robot, and we use that data, which consists of perception and proprioception data in the robot, to train an autonomous behavior policy, such as automotive sequencing. That means that these robots can come to your factory and you can teach them how to do new things. So we're no longer explicitly programming these robots with traditional algorithms. That would take too long. We want this robot to do all of your tasks, any kind of industrial task. So it's much more efficient to do that with the demonstration method. To scale that effort, we've also partnered with Google DeepMind. That was something that was announced here at CES. They'll give us way more data. Introducing the new robot. You can really see the dexterity in those hands and those grippers. Also notice we're going from 3 fingers to 4 in the new model. We decided we actually need another one to be able to handle all of the types of parts that we want to handle. Another wave. Thank you for your time, Atlas. And then it's going to walk back, and we'll see that reverse. We'll see it sit down, and watch again. It's going to go straight vertical down, and then curl the legs behind it.
A scalable robotics business that makes the kind of impact that we're looking to make, you need to take your hardware and your software, and each component within this system and solution needs to be reliable. It needs to be there when our customers need it most, especially on a manufacturing line that's working 24/7. It needs to be predictable. Operations teams and floor managers need to trust that Atlas is going to get the job done correctly. That when it runs into an issue or if it runs out of inventory, it knows exactly how to deal with the problem and who to notify when that problem arises. Atlas needs to be safe, and it needs to be really easy to deploy. If we're looking to not just produce thousands and thousands of robots, but actually deploy them into customer facilities at that scale, it needs to be fast and easy to get Atlas up and running on tasks and facilities, and getting Atlas to do exactly what you want it to do. About a year ago, we announced our first electric generation of Atlas, and this is the robot that we're actually demoing across the bay in our tech lab all day today. This is our research or prototype version of our hardware, and this is the version of hardware that we've been using for the last year to train Atlas on how to do all types of skills. This is the robot that we brought to the Hyundai Metaplan America factory a few months ago so that we could train Atlas in real-world environments with real factory data and start proving that humanoids can do real-world applications. We're learning directly from the operations team because they are the people that will actually use this robot, and they're the people that we need to hear from in order to build a product. Our latest generation of Atlas that we just announced is a culmination of that feedback that we got from hundreds of customers around the world. This is an industrial-grade humanoid. It is built for hard, rigorous work. Atlas can lift up to 50 kilograms. That's 110 pounds. That allows Atlas to take on tasks that are ergonomically challenging. Atlas can run 24/7. It has a 4-hour battery life with autonomously swappable batteries. We have 360-degree camera vision and an onboard safety system that allows us to detect people and behave very similarly to how you see Spot behave when you see people in forklifts moving around it. And finally, and most importantly, Atlas is built for reliability, manufacturability, and serviceability. A piece of hardware that works in the rigors of industry needs to be there when our customers need it. It needs to be easy to fix, and it needs to be easy to build. And so we designed this robot from the ground up so that that is possible. There are many other specs that make this version of Atlas really unique. Atlas stands at about 6 feet, 2 inches tall and can reach about 7.5 feet in the air. We have field replaceable limbs that allow us to easily repair and service the robot. We're able to work in harsh conditions, up to 104 degrees Fahrenheit or 40 degrees Celsius. This enables us to work in environments that aren't air conditioned. I'm sure many of you work down south in factories where it gets really hot. It's important to design a humanoid from the ground up with that in mind because it's really hard to lift up heavy weights in that kind of temperature. So Atlas was designed to be able to handle this weight. So there's a lot of talk right now about AI, and I really want to spend some time clarifying what kind of AI lives on Atlas and how do we train Atlas to do new tasks. An AI brain is similar for a robot to an LLM, or a large language model that you use every day, like Gemini or ChatGPT. Similar to an LLM, when you teach Atlas a new task, the more data you give it, the more skills it can do. This task here is Atlas picking up a spot leg, folding it, and placing it onto a shelf. What we did to train Atlas to do this task was physically teach it how to do the task over and over again, and then once you get enough hours of training data, that data feeds into an AI model that runs on the robot live. This is actually something that we're demonstrating over in our tech booth later today. So how do we actually teach the robot how to do the task? There's a few different ways that we do this. The first is teleoperation. This is having a person train the robot with a VR headset and sensors on their hands and feet. They physically embody the robot and teach it how to do the task. They repeat motions over and over again, showing Atlas how it should do a task. If Atlas fails, we correct it, and the robot's able to get smarter. This is probably the most straightforward way that we train Atlas because it's pixels to torque, meaning the robot's already done it before. So when you repeat it in a policy, it's done the exact motion. But we need to be more scalable. We're talking about building something as grand as a large behavior model or an AI brain. We need to be able to train the robot in simulation much faster and without hardware, and that's where reinforcement learning comes into play. This video that we released a few months ago of Atlas crawling, doing cartwheels, doing all sorts of athletic behaviors may have seemed more like a hardware feat, but what it really was a feat of research. We were able to show the robot how a person would do these tasks, simulate the robot doing it, and then have thousands of versions of Atlas repeat this motion over and over again in simulation. What this allows us to do is to get the robot to do things that we've never been able to get it to do before. Even just when we walked out on stage during Media Day 2 days ago, you might have noticed that the robot kind of had a swagger when it walked. That's thanks to reinforcement learning. We are able to make the robot move more human-like than we ever have before because we're able to train it in simulation through this way. And these are just some of the ways that we train the robot. On Monday, we announced our new partnership with Google Deep. They will be helping us ensure that Atlas has more onboard intelligence than we ever planned to before. We want to make sure that out of the box, Atlas has enough intelligence to be able to get started quickly on a task, so that when we come on site, we only have to do a short bit of additional training on our customers' tasks before we can get it up and running. But again, we need more than just hardware and AI to build an actual product that's useful to customers. In a few years, no one should care about this. No one should need to think about the hardware. No one should need to think about the AI. What they should be thinking about is whether or not the robot does the task the way they want it done. Does the robot follow the rules of the road? How do they train the robot? And that's what we're great at Boston Dynamics. Because of our experience with Spot and Stretch, we know that we need to be able to teach Atlas new skills in less than a day. We need to get Atlas up and running quickly, and we need it to be flexible. So that if customers need to change where Atlas is working, or if labor demands shift and change, it's easy to move Atlas to somewhere else in their building. We need to build configurable workflows. I'm sure many of you here work in facilities where you scan barcodes, and maybe you scan multiple barcodes when you're doing a specific task. Every area of a building has different rules of the road, and it needs to be Atlas. It needs to be easy to train Atlas on those different types of unique workflows that change as you move from task to task within a facility. This includes things like handling exceptions. What does the robot do when you run out of inventory? A person waves down a forklift driver. Is that how we want Atlas to interact with people? Maybe it is. Configurable workflows will enable us to work with customers to train Atlas to notify the right people in your building the way that you want them to, whether that's via API or just waving them down. And of course, that leads me to operator tools and interfaces. The way that people interact with Atlas, the software that we provide them with, is the only thing that they should be touching. Our Orbit software is how we do this with Spot. Customers have an interface where they can see exactly what Spot's doing. They can train it on new missions and new tasks that it needs to do. And we're going to be using the exact same software on Atlas to train it, to teach it, and for operators to understand what Atlas is doing, if it's doing its job correctly, the number of issues it's run into, and so on. So, the big question that everyone has is, when am I going to be able to get Atlas in my facility? When are you going to bring these three things together to actually deploy viable products into facilities? In 2026, we are going to be hard at work with Hyundai and Google DeepMind, getting Atlas to be smarter, getting Atlas to be more reliable. We're going to be training Atlas on real-world factory data and bringing more out-of-the-box intelligence to Atlas than ever before. This will enable us to go on site in a significantly more expanded way in 2027 with customers around the world. In 2027, if you're interested in a humanoid deployment, you can check us out at bostondynamics.com, where you can tell us more about what it is that you're looking for Atlas to do. Atlas will be doing industrial tasks, things like part sequencing, machine tending, loading parts into equipment, taking it out, order fulfillment. This is where we believe Atlas is a good fit to start, but you're the ones that understand your operations best. So if you think you have a place for Atlas that's a great fit, we want to hear from you. We want to make sure that we're building that out-of-the-box intelligence that will enable us to have Atlas work in your facility. So if you're interested in a partnership with us, please let us know. Thank you so much for having me today. It was great to talk to all of you. If you have more questions, I'll be around all day, and we have demos later today in our booth showcasing how we actually train Atlas. I'm Aya Durbin. Thank you so much for coming.
저희가 이제 원래 제 학교 프로그램으로는 CS가 있지 않습니까? 오늘 이제 어제는 유레카만 저희 관심 먼저 관심이 있어가지고 제공했습니다.
Thank you for using our service.
이 정도면 예, 재승아 상무한테 한번 전화 드려요. 손님 관계하고 있는데요. 이게 좀 들어오게 했는데.
So X-ble Shoulder is a wearable industrial robot that has been designed to reduce upper arm and shoulder load during repetitive overhead work. It only weighs 1.9 kilograms and offers a 0 to 180-degree range of motion, so it assists movement without restricting the worker, while reducing fatigue and injury risk. Let's check in with our volunteers. They're wearing the X-ble Shoulder main model, so when they raise and move their arms, they're feeling their strength being supported by the device. So on the wall, we also have some other vest variations. We have a work belt type that's designed for all body types and for high heat temperatures. We have a safety harness type that meets workwear standard for industries, and it's meant for working in heights. And then we have a high visibility vest, which is for low light working conditions. The aim of X-ble Shoulder is to provide safe, optimal support for each worker across a variety of industries, from construction sites to factories and beyond. They're going to wear a safety hat since they're working under a vehicle. So now the volunteers are going to be given a cable. They're going to connect the cables together. So they're going to connect the center cable together, and then they'll connect the rest of them from top to bottom in order. So they're working over their heads right now. This type of work over long periods of time can easily cause shoulder strain or muscle fatigue. But with X-ble Shoulder's assistance, workers work more stably and more comfortably. The final step is to twist the knobs counterclockwise until the light comes on. They did it. Nice job. Let's give them a round of applause. They did it. Yay! How was your experience with X-ble Shoulder? Good? They said it was very good. So while this was a short demonstration, for workers performing this kind of job for long hours, it can be a highly effective support solution. So now let's see how the assembled parts are inspected using Spot AI Keeper. So what you're seeing now is AI Keeper based off of Boston Dynamics Spot. And it's designed to inspect assembly quality directly on the production line. And Spot is unlike traditional industrial robots because he 4K inspection camera, and that's what Spot is using to get close and capture an image of the components that have been assembled. So he captures the image and sends it to our AI inspection server, where our system analyzes whether the components have been installed correctly. The results will appear on the screen in just a sec. And since Spot is finished with the task, he makes his way back to the battery quick changer to get ready for his next assignment. Once he's precisely docked, operations will start. The screen shows that the parts have been installed correctly. Nice job. The right side demonstration module was also inspected, and all components can be confirmed to be properly installed. Very good. So now, Spot is back on the battery quick changer, and the process can begin. Since it's fully automated, there's no downtime. The depleted battery is removed and a fully charged battery is installed.